Properties of rational number. Closure. What does closure mean? Closure in the simplest form means what kind of an answer you get when you add, subtract, multiply or divide two numbers of the same kind. It means that if your answer is the same kind as the kind of numbers, then you say that the type of numbers are closed, otherwise you say they are not closed. Let us take some examples to understand closure property. Whole numbers are the numbers from 0 onwards. Let's check closure for whole numbers under addition. What happens when you add two whole numbers? 0 plus 3 is 3. The answer is a whole number. 2 plus 8 is 10. The answer again is a whole number. You can add any two whole numbers. The answer will always be a whole number. So the whole numbers are closed under addition. That just means when whole numbers are added, the answer is always a whole number. Let's check closure for whole number under subtraction. What happens when you subtract two whole numbers? 10 minus 3 is 7. The answer is a whole number. Whereas 5 minus 7 is minus 2. The answer is not a whole number. So when you subtract one whole number from the other, the answer may not always be a whole number. So the whole numbers are not closed under subtraction. Do you understand what closed and not closed means now? Let's check closure for whole number under multiplication. 2 multiplied by 4 is 8. Answer is a whole number. 7 multiplied by 0 is 0. The answer again is a whole number. So when we multiply two whole numbers, the answer is always a whole number. So the whole numbers are closed under multiplication. Let's check closure for whole number under division. When we divide two whole numbers, let's see in the first example, 4 divided by 2 is 2. The answer is a whole number. Whereas in the second example, 11 divided by 3 is 11 upon 3. So when we divide one whole number by another, the answer may not always be a whole number. So the whole numbers are not closed under division. Let us now move on to natural numbers. Natural numbers begin with 1 and continue till infinity. Let's check closure for natural number under addition. 1 plus 3 is 4 and 6 plus 2 is 8. So in both the examples, when we add two natural numbers, the answer is a natural number. Therefore, natural numbers are closed under addition. Let's check for subtraction. When we subtract two natural numbers, that is 7 minus 3, the answer is 4. The answer here is a natural number, whereas in the second example, 2 minus 9 is minus 7. The answer here is not a natural number. So therefore, when we subtract two natural numbers, the answer may not always be a natural number. So we will say natural numbers are not closed under subtraction. Let us now move on to multiplication and multiply two natural numbers. 5 fours are 20. The answer here is a natural number. 3 twos are 6. The answer again is a natural number. Therefore, natural numbers are closed under multiplication. Next, division. Let's divide two natural numbers. 9 divided by 3. The answer here is 3, which is a natural number. Whereas in the second example, 15 divided by 2 will be 15 upon 2, which is not a natural number. So when we divide two natural numbers, the answer may not always be a natural number. So the natural numbers are not closed under division. Let us now move on to the next type of number, that is integers. Now integers include whole numbers and all negative numbers. So let's check closure for integers under all four operations. First, we begin with addition. Let us check closure for integer under addition and add two integers now here. So negative 6 plus 5, the answer here is negative 1, which is an integer. In the second example, negative 7 plus negative 2. The answer here will be negative 9, which is again a integer. Therefore, integers are closed under addition. Next, we move on to subtraction. Let us subtract two integers and check if the answer is an integer or no. 7 minus 5 is 2. The answer is an integer. Whereas in the second example, minus 5 minus 6 equals minus 11, which is again an integer. Therefore, integers are closed under subtraction. We now move on to multiplication and multiply two integers. 5 multiplied by 8, the answer here is 40, which is an integer. 7 multiplied by negative 2, the answer here is negative 14, which is again an integer. So when we multiply two integers, the answers are always an integer. Therefore, integers are closed under multiplication. Let's check for division now and divide two integers. 5 divided by 8, which equals 5 upon 8. So when we divide any two integers, the answer may not always be an integer. So integers are not closed under division. Let's check closure property for the next type of number, that is rational number. Now we know that rational numbers are the numbers which can be written in the form p upon q, and q should not be equal to 0. That is, the denominator should not be equal to 0. So let's check closure for rational number under addition and add two rational numbers. 3 upon 7 plus 2 upon 7 equals 5 upon 7, which is a rational number. So when we add two rational numbers, the answer is always a rational number. So rational numbers are closed under addition. Let's check closure for rational number under subtraction. Let's see what happens when we subtract two rational numbers. Minus 5 upon 7 minus 2 upon 3. So you'll have to cross multiply here because the denominators are not same. So the answer here will be negative 29 upon 21, which is a rational number. So when we subtract two rational number, the answer is always a rational number. Therefore, rational numbers are closed under subtraction. Let us now check under multiplication and multiply two rational numbers here. Negative 2 upon 3 multiplied by 4 upon 5. So 2 4s is 8, minus into plus will be minus, 3 5s are 15, that is negative 8 upon 15 is a rational number. So when we multiply two rational number, the answer is always a rational number. So rational numbers are closed under multiplication. Let us now check under division and divide two rational numbers. Negative 5 upon 3 divided by 2 upon 5. So the next step here will be negative 5 upon 3. Division when converted to multiplication, we will have to write reciprocal of the next number. So 2 upon 5, reciprocal of that will be 5 upon 2. So 5 5s are 25, minus into plus will be minus, and 3 2s will be 6. Let us take another example. Now here in this case, we have got the answer, that is a rational number. Let us take another example. 9 divided by 0, which will be written as 9 upon 0. And we have learnt earlier that rational number cannot have denominator as 0, which is not defined. Therefore, when we divide two rational number, the answer may not always be a rational number. Therefore, rational numbers are not closed under division. So today we have learnt closure property for whole numbers, natural numbers, integers, and rational numbers. Thank you.